Imagine boarding a spacecraft bound for Mars, knowing you will never return to Earth. It sounds like the opening scene of a science fiction epic. But for the future pioneers of the Red Planet, this is not a movie plot. It is a brutal, scientific reality. According to our current understanding of biology and physics, it is virtually impossible for a human who travels to Mars to ever live on Earth again. The barrier isn't a lack of fuel or the design of our rockets. The barrier is the human body itself. We are children of Earth, built for its gravity, protected by its atmosphere. When we leave, we don't just travel, we disintegrate. The journey to the Red Planet is one of the most extreme undertakings humanity has ever attempted. While it took us only 3 days to reach the Moon, Mars is a different beast entirely. A trip there takes between 6 and 9 months, each way. This means an astronaut will be away from home for a total of 2 to 3 years before they can even contemplate a return. 2 to 3 years of unprecedented stress on every cell of their being. At 55 million kilometers away, the isolation is absolute. Even light, the fastest thing in existence, takes 20 minutes to bridge the gap. In an emergency, there is no rescue. There is no evacuation. The nearest hospital is 8 months away. These astronauts are on their own, like no humans before them. But the true drama of this mission doesn't lie in the silence of space or the distance from home. It lies in what happens inside the body during this journey. A Mars mission exposes a human to 3 completely different gravitational environments: weightlessness during the long transit, the reduced Martian gravity at only 38% of Earth's, and finally, if a return is even attempted, the crushing full gravity of our home planet. Each transition is an extreme challenge, but the interplay of all 3 over several years has consequences that are still not fully understood. What scientists do know, however, is alarming. The human body is optimized for Earth. If we remove it from this environment for an extended period, a gradual process of change begins. A process that, after a certain point, becomes irreversible. We have seen it on the International Space Station. Astronauts who spend only 6 months in orbit often need weeks just to be able to walk again. Their bones have become porous, their muscles weakened, their hearts deteriorated. And that is after only 6 months, just 400 kilometers away from Earth. On a Mars mission, this time frame triples. The safety net disappears. When we think of the dangers of Mars, we imagine meteorites or technical failures. But the deadliest threat is invisible. It is the cosmic radiation that bombards the astronauts every single second, altering their bodies at a cellular level. Here on Earth, we are lucky. Our magnetic field and atmosphere protect us from 99.9% of this dangerous radiation. But in deep space, that shield is gone. An astronaut on a Mars mission is exposed to a dose of 870 to 1,200 millisieverts. That is 700 times more than what we experience on Earth. To put it in perspective, it is equivalent to 632 CT scans or 12,000 X-rays in just 2 to 3 years. The consequences are devastating. The risk of cancer increases by 10%. The cardiovascular system ages by decades. Most terrifyingly, the brain suffers measurable cognitive damage. Memory problems, slowed thinking, and difficulty making decisions become permanent. The eyes develop cataracts prematurely, and the immune system fails as the bone marrow is damaged. Conventional shielding is ineffective. Thick armor can even generate dangerous secondary radiation. The radiation is the first domino in a chain of physiological collapses that make a return to Earth a death sentence. While the radiation invisibly rewrites the DNA, something equally dramatic is happening to the astronaut's skeleton. In weightlessness, the body undergoes what can only be described as accelerated aging. It unfolds not over decades, but over months. Our bodies are masterpieces of evolution, designed to fight against Earth's gravity every second. Every step we take strengthens our bones and muscles. Gravity is the invisible trainer that keeps us strong. Without it, the body literally begins to disintegrate. The figures are terrifyingly clear. Astronauts lose 1 to 3% of their bone mass every single month. After 6 months, that's 18%. After a year, 36%. On a 2-year Mars mission, an astronaut could lose over 50% of their bone density. For comparison, a 70-year-old woman with severe osteoporosis has only lost about 30 to 40%. A Mars astronaut in their 30s will have the skeleton of a frail elderly person before they even reach the halfway point. The hips, the spine, and the femurs, the very bones we need to stand, become porous and brittle. The body decides that because these bones aren't being stressed, they aren't needed. It stops building them and instead excretes the calcium through the kidneys, creating a massive risk for painful kidney stones. But it's not just the bones. The muscles follow the same alarming pattern, atrophying at a frightening rate. The leg muscles and the core, the muscles that keep us upright, simply waste away. At the cellular level, something disturbing happens. Muscle fibers change from slow endurance types to fast twitch fibers. They fatigue almost instantly. Simple tasks like climbing stairs become impossible ordeals. Even the joints lose their structure. The cartilage that acts as a shock absorber becomes thin and brittle, leading to permanent osteoarthritis at a young age. On the ISS, astronauts exercise for 2 hours a day, but it only slows the decay. It doesn't stop it. And then there's the most vital muscle of all, the heart. On Earth, the heart works tirelessly to pump blood upward against gravity. In space, that struggle vanishes. The heart begins to shrink. Studies show that hearts can lose up to 20% of their mass. At the same time, fluid shifts upward, creating the puffy head phenomenon, while the legs become thin. The body, thinking it has too much fluid, excretes water, and blood volume drops by 20%. The heart becomes the pump of another planet, a weaker, smaller organ. This is the brutal reality of the Mars mission. After 2 to 3 years, the body is no longer built for Earth. It has become a Martian body. If that astronaut were to return to Earth's full gravity, the results would be catastrophic. Their shrunken heart would be too weak to pump blood to their brain against the resistance of Earth. They would suffer from severe orthostatic intolerance, fainting the moment they tried to stand. Their brittle bones would risk fracturing under the simple weight of their own body. The radiation-induced damage to their arteries would heighten the risk of immediate stroke or heart failure. The transition from 38% gravity back to 100% would be a physical trauma the body cannot survive. Although scientists dream of artificial gravity, we have no technology ready for deployment. The first humans to travel to Mars must be prepared to stay there forever, not out of a thirst for adventure, but because their bodies will no longer allow them to come home. They will look at the blue dot of Earth in the Martian sky, knowing it is a world they can never touch again. They will be the first true citizens of the Red Planet, bound to its dust and its low gravity by the very cells in their weakened hearts. The journey to Mars is not a round trip. It is an exile. It is the moment humanity decides that to reach the stars, we must be willing to leave ourselves behind. As we look to the future, we must ask, are we ready to send our best and brightest on a journey from which there is no return? The Red Planet is waiting, but it demands a price that is written in bone and blood.